Hi everybody. Today we're going to be talking about multiplying polynomials. So you want to check out page 4 in your packet, or activity 4 in your packet. And we're going to look at and review, because we already know how to multiply polynomials. So we're going to go back and talk about some different circumstances and how that's going to lead us down to being able to multiply here. When we don't have any plus signs in our expression, it's actually much easier. We can just say that this is negative 3 times x times x times x when we look at what this negative 3x cubed stands for. When we look at our 4x squared, we can say that's 4 times x times x. Now, you're not going to do this every time that you go to multiply, but it's important to take a look at and see how your negative 3 and your positive 4 are going to give you a coefficient of negative 12, and your 1, 2, 3, 4, 5 x's are going to be expressed as x to the 5th. So some important things to note here that we want to make sure that you realize is there are no parentheses in this example, and there's no addition or subtraction signs in this example. So we're just going to multiply coefficient times coefficient and then tally up our number of our variables, and we're set in that sense. Okay, so when we talk about when we introduce both the parentheses and that plus or minus sign, we change a little bit of what's going on. So what this 2 here as a coefficient means is that I have 2 of these. I have 6x minus 9 and a 6x minus 9, which means I have 2 6x's, which is going to give us 12 x's. And I have 2 minus 9's, which is going to give us minus 18. Now, we don't necessarily split things out all the time. This 2 means that I have the same thing twice. What we do instead is we use the distributive property. And I know that 2 times 6x is going to give me 12x. And 2 times negative 9 is going to give me negative 18. So notice I got the same answer 2 different ways. Using the distributive property is faster. Okay, let's take a look at this note. Remember, when we multiply polynomials together, we're going to have to multiply our coefficients, and remember, we're going to add our exponents together just like we did up here. And we want to think of this, remember, we called this in class more like a tally, so we don't get that confused. Okay, so when we look at this next example, I'm going to take 4x, and using the distributive property, I'm going to distribute that to every term. 1, 2, 3 terms. So that ends up being 4x times 8x squared minus 4x times 6x plus 4x times positive 5. So you can see each of the different terms here. Here's my 8x squared. Here's my negative 6x, there's my minus and my 6x, and then my 5 is right here. So I've shared out the 4x to each of these terms. When I go ahead and I multiply, I'm going to get 4 times 8 is 32. X and x squared means I have 3 factors of x. My negative is going to give me 4 times 6 is 24. X times x is going to be my tally of 1, 2 x's. And then, of course, here I have 4 times 5 is going to be positive 20 and 1x. This polynomial is my final answer. I don't have any like terms to combine. It's in standard form because I go from having 3x's to 2x's to 1x in decreasing order, so I'm in good shape. So our next example is going to be when I have a binomial here. Here I have a binomial, and then check it out. Up here I only have a monomial. So this addition sign in that one factor is what's going to change everything for us. And I want you to think about, we're going to have each individual part multiplied by each individual part. So I want to take a minute and ask you, do you remember from elementary school, if you had to multiply 32 times 14, do you remember what you used to have to do? I know we used to call it the bow tie method. We would do 4 times 2 and then 4 times 3. So we'd say 4 times 2 is 8 and 4 times 3 is 12. Then we would say add a 0, and then we would say 1 times 2 is 2 and 1 times 3 is 3. So you can see that little bow tie method. And then we would go ahead and add and take the sum of each of those rows, and that's how we would do that 2-digit multiplication. So if you remember in elementary school, that bow tie method made sure that you guaranteed to multiply everything by everything else. Well, in case you ever wondered why the heck you had to do this 0, what you were really doing here was 32 times 4 plus 32 times 10, and this 0 here for the 10 was what you had there. We're going to take that same idea when we multiply each of these individuals. In fact, I can rewrite x plus 4, and I can multiply it by x minus 3. In the same way that I broke this up, I can break up this too. I'm going to first take x plus 4, and I'm going to multiply that by my negative 3. And then I'm also going to take my x plus 4, and I'm going to multiply that by my x. So the interesting thing that ends up happening is I still have to do my distributive property for each of these values. This is going to give me negative 3x minus 12, and this is going to give me x squared plus 4x. If I were to go ahead and add them together, my x squared has no like terms. My 4x and my negative 3x combine to 1x, and my minus 12 has no like terms. So this splitting up may be a little confusing. So what we've done for you is we've come up with what's called a mnemonic. It's called FOIL. And our FOIL stands for making sure that we multiply our first, our outside, our inside, and our last terms. So if you notice here, when I multiplied my x times x, that's what happened during this part. This is the product of our first terms. Here's our first, and here's our first term. So the first term in each expression we're going to call our f, or our first product. 3 times 2 is 6, x times x is x squared. Then we're going to talk about our outside terms. Now our outside, if we think about this is the inside and that's the outside, This 3 is an outside, and so is this 5. So now I'm going to multiply these two outside terms. Here's the inside, there's the outside. So 3x times 5 is going to give me 3 times 5 is 15, and don't forget that x. Now let's talk about the inner terms. See, remember these were the outside, now these are the two inside terms. So I'm going to multiply my 4 and my 2x. These are my inside terms. Remember my 4 is negative, so that's going to be minus 8x. Finally, I have my last terms. So if these two were my first terms, now these two are going to be my last terms. So my last terms are going to be negative 4 and positive 5, which is going to give me negative 20. So if you look carefully, you can see by my colors, I have my first terms, I have the product of my outside terms, I have the product of my inside terms, and I have the product of my last terms. Now, sometimes, in fact, most of the times, this O and I are going to be like terms. So we're going to have to remember to combine those like terms. So when I look at this polynomial in standard form, remember that's what our goal is. Our highest power first, 6x squared. I had no other x squareds, so that looks good. Positive 15x's, negative 8x's combined to give me positive 7x's, and 20 is my only constant, so I have negative 20. This quadratic trinomial is the product of these two linear binomials. So by using a process called FOIL, I was able to multiply them together, and I made sure that everything was multiplied by everything else. Same as what we did in elementary school, in the same way we broke this expression down up here. This is a trick that we can use to make sure we know how to do it. All right, we're going to scoot down to number 3, and what I want you to do is I want you to try your trick. So I'll walk you through it. I want you to multiply your first terms together. That's going to be W times 2W. Now, a lot of times, I'm just going to do that in my head and call that 2W squared. That's my first product. All right, let's talk about our outside products. See how the 5 and the W are on the outside? If this is the inside, here's the outside. So this is going to be plus W times 5. That's going to give me 5W. Remember, your coefficient always goes first. Let's talk about your inside terms. Here they are. Negative 3 times positive 2W. That's going to be negative 3 times positive 2W is going to give you negative 6W. And now we'll talk about your last terms. Your negative 3 and your 5 is going to give you negative 3 times 5, negative 15. Remember, you're going to look for and combine your like terms. So your final polynomial in standard form is going to be 2W squared minus 1W, a positive 5 and a negative 6 is negative 1, minus 15. This quadratic trinomial is the product of these two linear binomials. Okay, so our foiling is our first method. Our second method we like to do is called the box method. I think maybe some of you are going to like this. So what I'm going to do is I'm going to draw the box. And inside my box is going to be my product, and outside my box is going to be my two factors. So I want you to see that I'm going to put a 3x and a minus 4 here. Here's where I got 3x minus 4 from. I'm going to put a 2x and a positive 5 here. So inside my box is going to be each of their products. Are you ready? So 2x times 3x is going to be 6x squared. 2x times negative 4 is going to be negative 8x. 5 times 3x, 15x. 5 times negative 4 is going to be negative 20. Now, come back here and you see there's our 6x squared, there's our 15x's, there's our negative 8x's, and there's our minus 20. If you look, we've had the same problem twice. So what I want you to see is each of these products here comes from each of these factors. And it's going to be real important that you remember what we call each of these things. So this here is a factor. This here is a factor. And then this end result here is what we call the product, is inside of the boxes. We can list those terms in standard form. 6x squared, positive 15, negative 8 are going to make positive 7x, and negative 20. Notice our quadratic trinomial answer is the same. Okay, so let's go ahead and draw a box for this next one. You're going to draw a box. And you're going to write, and it doesn't matter which binomial you put on top or bottom. So my negative 2a and my negative 4 can go here. My positive 8a and my positive 3 can go there. When I'm looking at finding the product, I'm looking at multiplying. So if you think about when you had your math fact charts when you were in elementary school, remember these two things multiply together to what is inside. Negative 2 times positive 8 is negative 16. A times A is A squared. 8a times negative 4 is going to be negative 32a. Negative 2a times positive 3 is going to be negative 6a. And 3 times negative 4 is going to be negative 12. When we go to list the product in standard form, I'm going to start with my highest power, negative 16a squared. And then I'm going to combine like terms. Do you see how this is a and this is a? They are the same variable to the same power. So I know that in total I have 38 a's that are negative and negative 12. Alright, so when we look at these next three examples, you'll notice something looks very different. And the first thing that's different is you can see that here I have a trinomial times a monomial, and a trinomial times a binomial. So we're going to have to think about multiplying these in the same way. Our FOIL is not really going to work as well because instead of having 4 terms for our first, inner, outer, last to be multiplied, we have a lot more than that. So what I want you to do is think back to when we talked about the pizza man coming and delivering pizza to every single person inside the house. The interesting thing is now the pizza man is also passing out soda. So we want to make sure that each of these terms is multiplied by each of these. So when I start off, I'm going to have my x is going to be multiplied by my negative x squared. I'm going to have my x being multiplied by my 3x. And I'm going to have my x being multiplied by my 5. When I look at that, I'm going to have negative x cubed plus 3x squared plus 5x. So that is just this half. I didn't include the negative 2 yet. That's just x. So now when I do my next part, I'm going to have negative 2 times negative x squared. And I'm going to have negative 2 times 3x. And I'm going to have negative 2 times positive 5. So that's going to give me a positive 2x squared. That's going to give me a negative 6x. And that's going to give me a negative 10. So this individual product line is shown here, and this product line is shown here. When I add them together, I end up with a negative x cubed, because he has no like terms to be added to. I have a 5x squared, because 3x squared plus 2x squared is 5x squared. I have a 1 negative x, positive 5 and negative 6. And then this negative 10 doesn't have any like terms, but that's okay. So I'm looking at here, my standard form is going to be each of those things multiplied. Now this one's actually easier than the one we just did. This negative 4x squared is going to be multiplied by each term. You want to think about the pizza man can come to the back of the house. He's going to pass out pizza for the distributed property to each thing. So negative 4x squared times 3x squared plus negative 4x squared times 2x minus, here's my 6, I'm going to have my negative 4x squared times, and that's that minus 6. So that's going to give me negative 12x. If I have 2 x's as factors and 2 more factors of x, that's going to give me 4 factors of x. This 4 is negative, so that's going to be minus 8x. Here's 2 x's as a factor. 1 more x makes 3 x's being multiplied together. And these two negatives are going to create a positive 24x squared. And that counts as standard form. My powers are decreasing from highest to lowest. And down I go. Alright, we'll continue on. Maybe you want to try the box method. Maybe you say 4x squared minus 3x minus 1 across the top of your box. And then on the side of your box, maybe you want to put 2x and negative 5. What's important to know is that instead of having 4 boxes, check out how many you have now. Yep, 6 boxes, because there's 3 terms in this one. Alright, so we have 8x cubes. 4 times 2 is 8. X times x is 3 factors of x. Minus 6x squared minus 2x. 4 times negative 5 is negative 20x squared Negative 5 times negative 3 is positive 15 x's. Negative 5 times positive 1 is positive 5. Now comes the fun part, combining all the like terms. 8x cubed is the only x cubed. But these are both x squared terms, minus 26x squared. Here we have plus 13 x's, and then my plus 5 is at the end. Okay. So when you're doing your practice, make sure that you look at each of these different kinds of examples, whether or not you want to do the box method, whether or not you want to use the distributive property, whether you have 3 terms, or just like these back here, having 2 terms. All right, our next conversation comes from dividing polynomials. And this is an interesting backwards thinking conversation. We just talked about multiplying, and now we're going to think about dividing. And when you understand the relationship between them, one undoes the other. So here we go. When dividing, rewrite your polynomial so that each term of the numerator has the value of the denominator. So we'll see what we mean by this. You see how I have 18x cubed plus 2x squared minus 6x to the 7th? We're going to split this up. Instead of having one division numerator, this numerator or this denominator is going to be distributed to each of the terms of the numerator. It's the distributive property. So my distributive property says divide this, and divide this. So I'm going to simplify and think about each one of these little mini fractions separately. So when I go to divide this, I'm looking at 9x's, because 18 divided by 2 is 9. And if I have 3 x's up here and 2 x's here, 2 of them can cancel out. Check out what happens here. 2x squared divided by 2x squared. Don't be fooled. That counts as a 1. Negative 6 divided by 2 is minus 3. 7 x's up top, 2 on bottom leaves 5 x's. So when I go to write this answer in standard form, I want to make sure that my negative 3x to the 5ths come out first. My 9x's are the next highest power, and then my plus 1 is at the bottom. So when we divide polynomials, we're going to break each term up into its separate parts so that this divisor is distributed to each of the 3 terms. So if I have 18 x to the 12th, y to the 3rd, that 6x to the 4th, y to the 3rd is distributed to that first term. My second term is 21 x to the 9th, y to the 5th. Guess what? That 6x to the 4th, y to the 3rd is dividing that term too. Next I have my 24x to the 4th, y to the 6th. And that's also being divided by 6x to the 4th, y to the 3rd. So just so we're all on the same page, in Algebra 1, these are designed to work out. So you're going to encounter some friendly numbers for sure. This looks like some of the exponent work we did last unit. 6 into 18 goes 3 times. If I have 12 x's up top, taking away 4 x's, that's going to leave me with 8. And those y's cancel out. 3 y's up top, 3 y's down bottom. Here, I'm going to have a fraction that doesn't work out evenly. When I factor a 3 out of each term, I get 7/2. Now, because all these x's and y's in the denominator cancel out, they all stay up top with the 7. 9 x's, take away 4 x's, leaves 5 x's as factors. 5 y's, take away 3 y's as factors, leaves me with 2. And here I have 6 into 24 goes 4 times. My x's cancel out evenly, and that's going to leave me with 3 y's. So when I look at this, yes, I do have standard form because I have a power of 8 up front. So my highest variable comes first. All right, go ahead and pause the video and see if you can do these next 2 examples and check back in. Okay, so check your work with mine. Each term, each of the 3 terms gets divided by 5, leaving me with 3x cubed plus 4x squared plus x. My 5's cancel out, but you still have an x there. 72x to the 4th divided by 3x squared is 24x squared. 81x cubed divided by 3x squared is 27x's. My 9x squared divided by 3x squared is just my 3. Each of these answers is in standard form because I go from highest power down to lowest. All right, so make sure that you finish the practice problems. Make sure that you do math space and the e-cart. Come to class with questions.